All right, I think we're going to go ahead and get started. Once again, welcome everyone. Thank you for joining the annual Technology Baseline 2020 webinar. My name is Jackie Petrie. I just want to go over a few quick housekeeping items before we start today's presentation. So we just want to make sure everyone is aware that this presentation is being recorded. We will make a recording available after the webinar on the NREL YouTube channel. We'll make sure that everyone has a link to that. If at any point during today's webinar you experience audio issues, we recommend that you try switching from computer to phone audio. You can do that within the GoToWebinar tool. You'll see the panel on the right of this slide. If problems persist, you can contact GoToWebinar's technical support. The number is on the screen in front of you, but you can also submit a question to us if you're having trouble with your audio, and we will do our best to help address it. If you have other questions throughout the webinar, you can submit your question using the questions panel within the GoToWebinar interface. We will answer both during and at the end of the presentation as time permits. If we do not address all of your questions, you may submit them via the website. And with that, I'm going to hand things over to Laura Bimmerstedt. Laura?
Hello, everyone. Welcome to the ATB webinar, and thank you for joining. We know that some of you are new to the ATB, and some of you have been familiar with the ATB in past years. So some of this presentation may be review for those of you who are more familiar, but we hope that everyone finds something of interest today. I'm going to talk about why the ATB first, and then give an overview of the project and provide an overview of the cost and performance assumptions that we're making in the new projections. The entire technology analyst team will be presenting briefly on technology-specific highlights, and we'll also talk about revised financial cases and methods for this new ATB. At the end of the session, we'll have questions and comments. So that's the agenda for today. If you have any technical issues, as Jackie mentioned, you can let us know. Rolling into the agenda, why the ATB? So we're faced with an ever-changing landscape of technologies, and we really need to continually update those technology costs and assumptions so that we have a single data set that can help us to understand technology cost and performance across the energy sector. So to answer this need, we provide this transparent and consistent set of technology costs and assumptions for both internal use by the energy efficiency and renewable energy portion of the Department of Energy, as well as the labs such as NREL that work on EERE analysis, as well as third-party analysis for participants across the energy sector. The ATB is used in many of our models, such as the resource planning model, the regional energy deployment system model, and the system advisor model, as well as reports from national labs and from the Department of Energy. And it has proven useful to a whole lot of different participants, energy planners, academics, analysts, and many others. So the assumptions in the annual technology baseline are used in the standard scenarios report that NREL produces. And oftentimes we field questions through the ATB that are more scenario analysis questions that are answered within the standard scenarios report. So the ATB includes a whole suite of products. For a long time, we have had the spreadsheet, and we have updated that this year. We also have the website that documents that spreadsheet. The past couple of years, we've extended the suite of products to include the formatted data, Tableau workbook, and this year in particular, we feature new interactive charts on the newly developed website. So the core ATB data items, the capacity factor, the O&M costs, the CapEx, financing assumptions, and then the calculation of the levelized cost of energy. Those data are all available in these different formats that can be downloaded and used in other ways. And then we have finally PowerPoint. So the PowerPoint from the webinar, the Tableau figures can be downloaded into PowerPoint form, and we will also soon be publishing a set of PowerPoint slides. So we have an enhanced set of products this year. The ATB takes this set of metrics, CapEx, O&M, and capacity factor, and produces a flawed but useful summary metric, the levelized cost of energy. And we cover the set of technologies that you can see on this slide kind of at two different levels. So for the renewable energy technologies, we spend considerable effort both establishing what the base year cost and performance are, and so we do our own original research on how those technologies are doing with deep knowledge from our technology analysts. We capture the conventional technologies differently. We refer and rely heavily on the EIA's annual energy outlook for those. So while we cover all of these technologies, our coverage of them differs. So for the technologies, the methodology relies on the 3 steps shown here. We bin the resource, we consider the cost and performance data in each bin and calculate the LCOE. So this slide portrays the bins for each of the resources and what distinguishes the difference between the resource bins. One important change this year is that the wind bins are now based on the wind speed, not on technology resource groups, as was done in the past. So for example, here is the slide of the land-based wind resource groups. So the capacity factor is different for each of the wind classes, and we use the class 4 as a default. So for each of the technologies, the resources binned by quality, and then we select a default that we use to display many of our visuals. However, the other levels besides the default are also available in the interactive charts and in the data set. So then we develop cost and performance data for each technology. And this year, what's new is that we've gone to more effort to ground these assumptions in technology innovations. So we have added some more explicit descriptions of how the technology is expected to change in order to achieve future performance improvements, and how those assumptions differ between the scenarios. So what's additional in the advanced scenario that has not been a successful technology innovation in the other ones, for instance. And so we developed these cost and performance assumptions for both the base year of 2018 and for the projected years through 2050. And this slide summarizes those sources for the base year. And this slide summarizes the major innovations for each technology that are driving those projections to 2050. So then we calculate the levelized cost of energy from the core technology cost and performance assumptions. And of course, levelized cost of energy is not a comprehensive metric that addresses all of the issues that need to be considered in system integration of technologies. So we use it as a summary shorthand, but of course it's not a comprehensive metric. So at this point, I will turn to a cost and performance overview. So for all of the technologies, what has changed in 2020 is that we have new financial assumptions. So we still have the R&D case, which does not take into account things like tax credits. And then we have a market and policies case that is somewhat different from last year because it's newly based on a financial report that was focused on renewable energy technologies and developed data on the actual finance of those technologies. And then, as I mentioned before, we have several new products. Interactive charts are downloadable in PowerPoint and a variety of other formats as images as well. Tableau workbooks that can be downloaded individually or as an entire set in a zip file, CSV files, and a summary PowerPoint. And then the other change is that we've updated the base year to 2018, and historical data is now through 2018. The dollar year is 2018 as well for all of the dollar values in the ATB. So at this point, I'll turn to a web demo. So I've done the project overview. We're talking about the cost and performance overview. So I'll demo that on the web. And then the remainder of the presentation will address the final topics there on this slide. So switching over to the website. So when you go to atb.nrel.gov, this is our landing page. When you click over to electricity, you come to this data overview page. And here you can see a snapshot of the renewable technologies, the levelized cost of energy for all of the different resource levels. So each of the little blue dots is a different class of resource, and the orange is the default that we use where we need to pick one. So this is defaulting to the base year of 2018. The second slide shows the projections, and then the third image is a table with all of the different parameters. So there's a lot of good information in the definitions to interpret what all the different terms here mean. And if you click on the more details button, you go into the interactive mode where you can choose among the different parameters, technologies. So right now, the renewable subset of the technologies is selected on this chart, but you can choose others as well. You can choose among CapEx, O&M, capacity factor, fixed charge rate, different scenarios, different financing cases, cost recovery period, and year. So this filter selection pane is pretty standard across many of the charts, and you can use this to dive in and explore what you might be most interested in within the data set. And then these are also, when you download the data, you download all of these different aspects of it as well. So diving in to look at an individual technology page. So for each technology, the individual technology pages display all of the different parameters. And again, you have choices between which financial case you can zero in on particular parameters or particular scenarios. And this is also where, looking at all of the different classes of resource is one of the dimensions that you can drill down into. So this shows all of the resource classes, whereas by default, we're just showing the class 4. So that's the individual technology page, and each of the technologies is structured the same as this, with the possibility for interaction on the chart. Then we have a comparison view between 2020 and 2019. So if you've used the ATB in the past, you can see where the technology's assumptions have changed. We have the documentation of the financial assumptions that shows the comparison between the two different financial cases. So if you pick the all of the financial options, you can see that comparison here. And then all of this data is downloadable from the download site, either as the spreadsheet or CSV or Tableau. And then importantly, any of the figures on the site, once you've interacted with them and made selections that you want, you can hit this download button and download it as an image, cross-tab PDF, PowerPoint, Tableau. So there's basically two places where you can download. Any place on the site where you see this download button, or in the data area. When you download Tableau in the data area, you get all the workbooks at once, and there's 17 in all. So basically those are different subsets and different views of the data. If you go and download it here, you just get the workbook that contains this particular visualization. So there's also a lot of really important detail in the about part of the website. So, detail on the methodology, which is now based more on technology innovation, specifics of the equations, the financial cases and methods. So that new financial assumptions report that just came out is summarized here. Definitions, all of this is really good information. So we hope that the new changes to the website this year are going to be helpful to everyone, and that's it for the web demo. Let's see, I guess before I switch gears, or as I'm doing so, are there any questions coming in that I should answer right away?
Yeah, I think there's one we could discuss now. The question is, could you please talk a bit more about how interconnection costs are represented in the cost data for all technologies, especially for offshore wind?
Yeah, so I'll turn it over to Philip to address the specifics of offshore wind, but in general, it's a kind of a minimalistic approach to that, so it's not at all specific, but there's a, for most technologies, the cost of a short spur line is included, and those assumptions are documented in that About section of the ATB. Philip, did you want to address the specifics on offshore wind?
Yeah, thank you, Laura. So the interconnection costs are obviously particularly important for offshore wind. We do consider the expenditures for the export system cable, the array cable connecting different turbines, as well as the spur line from the cable landfall to the nearest grid feature. And those are reported as part of CapEx in offshore wind. Obviously, the methodology is slightly different for the other technologies, as the interconnection costs are relatively smaller for other technologies, but that's how it's treated in offshore wind. I think I'd also like to point out that the ATB cost does not reflect any costs associated with upgrading the onshore substation or any upgrades to the broader bulk transmission system.
And Philip, if you want to go ahead and roll into your overview of offshore wind, that would be fine.
Sure, thanks. Yeah, so for offshore wind, we've estimated this year's ATB costs as in previous years with the Offshore Regional Cost Analyzer, or ORCA, an NREL model that allows us to estimate the costs and performance of offshore wind plants at more than 7,000 sites in the United States, using both fixed bottom and floating technology. In our cost modeling, we consider a suite of spatial parameters such as wind speed, mid-ocean conditions, bathymetry, the distance to construction and O&M ports, and a few others. Obviously, there's been a lot of activity lately for the past couple of years really in the offshore wind sector, which has allowed us to validate our cost estimates. So we've conducted an effort to analyze the long-term contracts that were signed between offshore wind developers and utilities, really giving us a bit of a benchmark in comparison to early years for our cost estimates. Now looking at the costs and performance here compared to last year's ATB, there's fairly good alignment with only smaller changes, at least for this representative wind speed 3 class that's depicted, which is meant to represent sort of the wind speed class that we'll see moving forward in terms of commercial deployment in the mid-2020s. So for CapEx, we're looking at an estimated value of just above $4,000, reducing to a level of around $2,000 per kilowatt by 2050. For fixed O&M, a level of around $130 per kilowatt year, down to about $55 per kilowatt year by 2050. Giving us an LCOE of around $100 per megawatt hour in 2019, reducing to just below $50 by 2050. The anchoring point for this analysis, or for the ATB for this representative class, when it comes to CapEx, is around $3,500 per kilowatt, which from our research is representative of some of these contracts that were signed for projects with a commercial operation state in the early 2020s. The reductions in costs that are shown here are the result of basically 3 key drivers. So the first one would be an increase in turbine rating. So we're using for 2019 a turbine rating of 5.5 megawatts, which is the average turbine rating that's installed globally. By 2030, we're assuming a turbine rating of 15 megawatts. And that increase in turbine rating does induce economies of size as developers have to install and maintain fewer turbines for basically the same power output. The second driver is technology innovation that is agnostic of turbine size. So that would be things such as the integration of high fidelity modeling, advanced control strategies, further digitization, and improved site understanding. And the third category we've analyzed here to develop basically the CapEx and O&M projections specifically would be basically improvements in the supply chain and learning, higher standardization, and economies of scale.
Great, thank you, Philip. Any questions coming in for Philip to answer right away?
Not so far.
Okay, so I'm going to jump back to the technology overview. So essentially, in this section of the presentation, each technology analyst is going to provide a brief summary of the technologies, similar to the one that you just heard from Philip for offshore wind. And in general, the updates by technologies, some of the technologies have more extensive updates than others. And in general, as you heard from Philip, we're trying to base the projections more strongly in the technology innovations. So that's a big theme that you'll see here. So we've tried to incorporate recent analyses as well as providing more detail on what the innovations are that are driving the changes in technology cost and performance. So with that, I will be calling on each of the technology analysts in turn, and we'll spend about 3 to 5 minutes on each technology. If you have technology-specific questions, now's a great time to put them into the question box, and we will try to go ahead and answer technology-specific questions as we go. So Tyler?
Yeah, thank you, Laura. Go ahead.
Yep, go ahead.
Okay, sounds good. Yeah, so as Laura described, we have a snapshot here of the land-based wind technology projections. And as you saw for offshore wind, we're here overlaying last year's ATB with this year's ATB for this one particular case, the default case. And as you can see, in general, there isn't a large impact or change from last year's ATB to this year's ATB. However, we'll make a couple of notes. There's a bit of a change in the CapEx cost estimates due to some changes in technology characterization, representation, primarily in 2030. The year 2030 was updated from last year. Primary characteristics, we assume the turbine's nameplate rating, hub height, and rotor diameter all increased from last year's. These changes were also based on updated literature reviews and data provided by wind industry consultancies. You can see a little bit of change in capacity factor over last year's. The most significant change here is the introduction of the 10 new wind speed classes that Laura alluded to earlier. The new wind speed classes do replace last year's techno resource groups. This change of rebind the national supply curve, which adjusted the annual average wind speed within each of the 10 bends. So in turn, this did change the energy production estimates that we've conducted. The update to the new wind speed classes was primarily done to better align other modeling efforts within the laboratory. This would be such as the renewable energy potential modeling, regional energy deployment system modeling, and the standard scenarios work as well. The performance estimates were also impacted by that change in technology that I mentioned in 2030, where you do have larger or higher nameplate ratings, higher hub heights, and larger rotors in 2030 compared to last year. The operational expenditures assume or draw on the same body of work as last year's ATB. This is coming from the benchmarking O&M work led by Lawrence Berkeley National Laboratory in collaboration with NREL. This body of work was published back in 2019. And then in results, you do see a similar LCOE reduction trajectory in this year's ATB as in last year's 2019 ATB. So that's a brief high-level summary. Yeah, I'll field any questions if there are any.
Yes, one question that's relevant to the different wind speed classes. Where could an analyst find a map or node to determine where resource classes are applicable?
So we do have in the documentation on the website kind of the range of wind speed bins where these new wind classes lie. There is work ongoing with the REV modeling team that I believe will have some published documentation on the whole, where the geographic or spatial points where these different wind speed bins lie. I don't know if anybody else on the REV, more knowledge on the REV team has to add to that comment.
Hey, Tyler, you might also address kind of the distinction between the resource data that we have at a very fine grid geospatially versus the binning and sort of the circumstances under which each of those is used in our analysis and might be appropriate for use in other people's analysis, right? Because someone can go and you know, look at the data and figure out the exact wind speed of a specific place, and there's not necessarily a need to worry about which bin that place happens to be in.
Right. So for this effort, yeah, for the binning process, at least for the LCOE calculations and energy estimates, yeah, we selected basically that range of wind speeds, which produce the average annual average wind speed, in which we took the specific characterization of the wind technology and power curve and estimated the energy production within each of the bins. And then within each of those bins, we have an estimated capacity or percent or fraction of the total supply curve for the national supply curve for land-based wind projects.
Yeah. So the binning helps a product like. Sorry, go ahead.
So there's one more question if we have time. Are the same nameplate power, height, and diameter used across all sites across all resource classes?
Yes, so that is a true assumption. It's a simplified representation for, yeah, the conservative, the moderate, and advanced cases. They are applied to, that same technology is placed in each of the wind bins throughout the nation.
Yeah, and I think it's really important to note, again, that these assumptions are made for kind of a high-level tool like ATB, or in some cases, similar simplifying assumptions are needed in some of our modeling. But for example, if someone is looking to understand the performance of a particular wind turbine in a particular place, you know, a tool like the System Advisor model could take in all of the actual data for that turbine and all of the actual data for that specific place, and you know, without any of these approximations that are used for these higher level summaries. So I think that you know, oftentimes we get questions coming in about the ATB that relate to these more site-specific performance questions, both in terms of the technology, like that last question, and also in terms of the resource. Anything else on the land-based wind technology-specific area?
Yeah, there was a follow-up question. If the same technology is used in all wind bins, why do the CapEx costs vary across wind bins?
Yeah, so that was a generalized assumption where at your higher wind speed classes, you'll have to increase the design of the wind turbine to sustain higher wind speeds. So you are potentially going to spend a bit more on the CapEx. So in the methodology that we used was we kind of clustered these CapEx estimates into 5 different areas where we have a very high wind speed site, high wind speed site, moderate site, low wind speed site, and very low wind speed site. And CapEx will generally decrease or increase depending on those assumptions of the wind speed within each bin. So there's a generalized assumption that, yeah, wind speed does impact CapEx over the wind speed classes.
Great, thank you, Tyler. So we'll move on now to photovoltaics. Dave, do you want to take it away?
Sure. Thanks, Laura. So we did a bunch of changes this year for PV. The first being we came more in line with other technologies. Previously, we had based our CapEx projections on a literature review results, looking at the past, I think, 3 years of literature projections. And this year, we've switched to more of a economic analysis of benchmarking costs in now and in 2030. And looking at sort of some of the technology improvements that are with a percentage of likelihood in the moderate, advanced, and conservative case. Obviously, different percentages of likelihood for those. So that analysis is based off of a bunch of discrete items, looking at the PV system, the module, at the inverter, the labor, some of the other permitting, and then sort of the overhead, the other soft cost areas. A lot of the improvements are driven by assumed module improvement, module efficiency improvements that are based off of, I guess, in that way, literature of we looked at projections from the industry on where module efficiencies are expected to go, and based our analysis off that, and looking at sort of how that might improve costs, and not just at the module level, but obviously by having a more efficient panel, it requires less labor per watt to install, and less material, things like that. But other improvements as well beyond efficiency, such as design simplification, manufacturing automation, using different types of products. So, for example, like for the inverter, using medium voltage power transmission affect cost. And then, I guess, lastly, and this doesn't affect in our analysis, it's not affecting CapEx. In our analysis, we assumed the improvement would show up on the capacity factor, although in reality that might not be the case. But we assumed improvements in energy yield, and so in that way, you can see that there's a difference in energy yield between this year and last year. I should also mention that some of the differences, or a good portion of the differences between this year and last year, also because of the second thing we did for utility PV, but not for residential and commercial, which is for utility PV, we are using the values are quoted in alternating current AC versus last year. We use DC because residential, commercial were and are still used DC. So I guess for utility PV, we this year are trying to be more consistent with other technologies rather than being consistent internally with the other PV technologies. And so those are some of the big, I should say that, I guess, when we're looking at our CapEx numbers, we also did a literature survey just to compare, and our based off of recent literature, the high, medium, and low are fairly consistent with other projections. Also, you could sort of, lastly, as just mentioned, the LCOE, you could see an improvement between this year and last year. Some of that is due to the things I explained or I mentioned. The other thing I should mention is that there was a change in financing costs, which we'll get into later, but that's another driver for differences in LCOE from this year to last year.
Great, thank you, Dave. Any questions about utility scale PV?
So the one question so far is this is a very dramatic change in capacity factor from 2019 to 2020. What's driving that?
Yeah. So yeah, I probably didn't explain it as well, but so one of the things is if you it's noted on the slide, but I don't, there's a lot of information here. The blue line is in all the blue lines are in DC, so and the orange lines are in AC. So some of it is just a difference in sort of what is being with the units. So that difference between I think all the difference between the blue and the orange line, at least in like 2018, has to do with just the fact that they're in different units. And you could also see that there's an improvement over time. I guess I didn't explain this well enough, but you notice an improvement over time. And that's due to our things that we also assume improvements in energy yield over time, and things like the inclusion of the adoption of more bifacial panels and the improvement of bifacial panels over time. So things like that, or improved O&M practices. There's a bunch of things that we assume for why that yield would go. But as far as the difference between this year and last year, at least if you just look at 2018, that's just the difference between the capacity factor in DC versus AC.
One more question. Are near-term CapEx and capacity factor numbers seen in recent projects?
Yeah. It's sort of tough to, I mean, it's a complicated question to answer, but certainly the capacity factors in AC are well within the range of what is being reported. If you look at data, Lawrence Berkeley has really great work out there on reported numbers, which should definitely check out. And so these are well within the range. As far as CapEx go, also, yes, well within the range of what's reported. It's kind of difficult to say exactly because so much of what is reported is historical, and this is sort of now and in the future, so it's a little bit different and sort of what is included in CapEx. But certainly if you take a look at the LCOE, both LCOE without the ITC, it's very much in line with what EPA prices are being quoted in large parts of the U.S. So it's, yeah. That's all I'll say.
Great, thank you, Dave. Yeah, go ahead, Brian.
There were a couple questions about the inverter loading ratio. It's recently increased in the ATB from 1.3 to 1.35. What caused you to make this change, and why don't you expect a continued increase over time?
Sure. We made the change, I think it was to 1.34, but maybe it's because of reported data, again, from the LBNL, the most recent report showing, and again, we model, actually, I should say again, for the first time I'll say, we model a one-axis tracking system here. And so that's what's currently being used. As far as what, we didn't assume any change in the future, because there's just a variety of things that could impact inverter loading ratio as far as sort of in the future, and so which would sort of, in some ways, you're robbing Peter to pay Paul sort of things. So rather than sort of trying to maybe be too clever by half. We thought we'd keep it the same and show the sort of technology improvements that we sort of are more straightforward in these results.
Brian, was there another one?
I think we can come back to some of the others at the end of the slides.
Okay, great. Dave, thanks so much. Moving on, Parthiv, would you like to address concentrating solar power?
Yes, here we go. That worked. Can you hear me?
Yes.
Hi, Laura. Hi, all. So yes, concentrating solar power is being shown, and it's worth highlighting that the moderate scenario is currently in orange, the 2020 estimates, and the 2019 is in blue for CapEx, capacity factor, O&M, LCOE, and variable O&M. It's worth highlighting that the reference currently is a molten salt power tower expected in the US, but then the cost projections are based on literature and market analysis and data from the global markets. We see that that's a suitable transfer. When we look at things like the capacity factor, only one class or resource is shown, and that's for California at around 64%, so 0.64. There are two other main areas that are part of the ATB data, which are class 5 for California, class 3 for Phoenix, and I believe class 1 for Texas. In terms of a potential LCOE, if we look at the fourth chart, the current expectations are that LCOE could be at around $50 per megawatt hour, close to 2030, in a in the current environment. And in the documentation, you'll also see that in the moderate as well as the advanced scenarios, there is the discussion and the improvement on CSP, which includes next generation high temperature working cycles like supercritical CO2, as well as higher temperature storage materials such as advanced molten salts or molten chlorides, for example. Any questions or anything else that I can highlight, Laura, on that?
Thanks, Parthiv. Any questions coming in from the audience?
Yes, there was one addressing whether this was only looking at power towers, and here we are. I don't know whether there were other concentrating solar power technologies represented here.
Yeah, great question. So I'll address that in the chat, as I've already answered in the chat, but it's great to mention it as well. Right now, the current representation is molten salt power tower because that has been shown to have a significant cost reduction potential. But with the markets like in Morocco and in Dubai, it's clear that large-scale parabolic troughs are also being built at several hundred megawatts. So realistically, for next year, we are in discussion on updating our reference situation to include parabolic trough as well as molten salt towers. But for this year, it's just one technology, correct?
More questions coming in now. One is, do these costs include thermal storage associated with CSP?
Yes, good question. That is built in at the representation currently is for 100 110 megawatt electric site with 10 hours of storage. And it's expected that all CSP plants, or the majority of CSP plants going forward, would also include 8 to 10 hours, or perhaps in some cases up to 15 hours of storage.
And what's driving the significant reduction in variable O&M costs after 2020?
Right, thank you. So after 2020, there was some work done with DOE on advanced power cycles, such as the supercritical CO2 cycle, but also the expectation is that learnings from the market would also be being brought back into the US as well.
Okay, thank you very much, Parthiv. I will move on at this point to geothermal. Yep. Greg, are you there?
Yeah, thanks, Laura. So as part of the 2020 framework, we performed bottom-up cost modeling using the DOE's GET'em tool. GET'em stands for the Geothermal Electricity Technology Evaluation Model. That was used to estimate CapEx and O&M costs for flash, binary, and EGS resources, or enhanced geothermal systems. Now those costs were estimated for a full range of known and undiscovered resources, but the costs you see here on the slide are for representative power plants due to the site-specific nature of geothermal resources. So the main updates to the base year were including the 2018 producer price indices from the Bureau of Labor Statistics. That accounts for most of the increase in CapEx that you see between the orange and the blue. In addition, we adjusted the finance model to reflect the higher initial cost of capital for geothermal developments. And I'll just say that the PPIs, they reflect inputs such as cement, steel, and pumping costs, and they were higher this year than what was previously used. And the main effort was to bring these costs in alignment with DOE's 2019 GeoVision report, which laid out several scenarios for geothermal development into the future. So the major technology innovations that we captured were drilling advancements, such as increased drilling rate of penetration and bit life, as well as EGS development, which included well stimulation success rate improvements, improvement in the control, well stimulation and reservoir creation, and sustained well flow rates. You can see the improvements are modeled linearly and incrementally with full realization in 2030. And then beyond that, we use a minimum learning rate to 2050. So some of the major reductions in LCOE are due to those financing adjustments, which impact the way we model project finance and construction finance. And I think that's all.
Great, thank you, Greg. Any questions coming in about geothermal?
We had one question asking for a comment on closed loop geothermal, which doesn't have the issues of traditional and EGS geothermal.
Yeah, thanks for that. NREL is currently looking at closed loop. We're calling it advanced geothermal, or AGS, to fit with our acronym system. But we haven't reached a point, and the documented literature hasn't reached a point where we can reliably estimate a cost for that. So I think it's at a very early stage, and there are several companies involved in this. So we're actively discussing this with them.
And Greg, could you just maybe briefly define what that system entails?
Sure. So with traditional geothermal, you're actually pulling hot fluid out of the ground. And AGS is sort of designed to mimic that through an engineering process. Closed loop is a contained system, so the fluid never actually touches the reservoir. So what you pull out of the ground is what you put into the ground. So you're just trying to capture deep heat from the earth. And the question is whether you can do it efficiently and without losing too much heat on the way to the surface.
Thanks. Other questions about geothermal?
Not at this time.
Okay, moving on. Debo, are you on the line?
Yes, thanks, Laura. Just briefly, for hydropower, we did not actually change much of the data this year. So the differences that are seen here are mainly due to new updates to the new year, as well as changes in the financial assumptions. Essentially, the production tax credit was incorporated. I think there's a discussion of that later on. So this data is kind of a bit dated, and we're working to produce estimates that are more reflective of the remaining resource for hydropower. Some of the data used for these estimates were based on existing resources that are significantly different from the remaining resources. So we're working on generating new estimates and hoping that by next year we'll have updates to this. But we did this year add to the literature review and historical estimates of component of the ATB. So there's really not much new to discuss here, and so I'll stop there.
Thank you, Debo. And I guess just to emphasize the point, the big difference in the LCOE is almost entirely due to a change in financial assumptions. Any questions coming in about hydropower?
Yeah, there was a question about the size of the system, whether this qualifies as large hydro or small hydro.
Yes, so most of this will be in the small hydro area, because most of the remaining resource are small compared to the large systems that we have in place right now. But the cost data that was used to estimate the functions behind the this category of hydropower were based on larger systems, and so they're not representatives of the actual resource itself, and that's what we're trying to address. But most of these will fall in the small hydropower category. The one that's shown here, which is one of the most likely to be developed resource, is potentially larger than the rest of the group. I think 30 megawatts is what we used. But even that 30 megawatts is small compared to the largest systems that we have in place right now.
And Debo, I wonder, I know that the main update to this is in process and not yet reflected in this data. But in terms of the technology innovations that are under consideration, I wonder if you'd perhaps just want to mention those so that folks can have a sense of what's coming, next year, we hope.
Yeah, so next year, apart from the innovations, a big change is likely to be the base cost, because the resources that are left are really the lower end of the hydropower resource spectrum. And so we're likely to see a higher base cost that is in the first year, maybe 2020. And then we're looking at innovations that are going on, that are under research. There is the small modular hydropower, which is designed to encourage scalability. There are several DOE funded for us looking at that. There are innovations also related to environmental costs, environmental impact mitigation costs. So there are turbines that are being developed right now and the DOE is funding that will allow fish passage through the turbine with minimum impacts. And that can save quite a bit of amount on these small hydropower systems, because the environmental aspect of building them is a larger proportion of the cost compared to the larger hydropower system. So if you can save 10% of that cost by building a turbine that actually doesn't require a separate fish passage, at least downstream, you can save quite a bit of money. So those kind of innovations are being looked at, as well as just getting a better understanding of the resource base that's left for hydropower.
Great, thank you. Okay, so moving on, we also in ATB have battery storage, so that's a little bit different from the renewable generation technologies. And Wesley, if you would like to address that, and perhaps also while you're on the line, perhaps you could also address our treatment of the conventional technologies.
Sure. Yeah. So our battery storage and conventional technology is a little bit different. So battery storage, we take our starting costs from the NREL benchmark reports and then project those costs forward over time using literature projections. So we look at literature projections and how much cost reduction is seen in the literature and use those to develop our own low, mid, and high cost projections. These are put in the ATB by, there's an energy component and a power component, so you could build up different durations if that's what you're interested in doing. So that's all in there, but it's definitely a different approach than you've seen the other technologies and the very specific elements that are coming in there. And outside of this initial cost that is pretty detailed, the cost reduction piece is less sophisticated and just based on literature. Our conventional technologies, our natural gas, coal, biopower, nuclear, those are taken from the EIA's, Energy Information Administration's Annual Energy Outlook reference case projection. We adjust them slightly by remove a material price index that's part of that. But otherwise, the numbers are taken from them and just ingested into the ATB, because that's what we use for all of our modeling work for the conventional technology costs.
Great, thank you, Wesley. Any questions coming in about battery storage or conventional technologies?
One question that came in earlier was asking about the report that's cited on the battery storage page, if there was any estimate of when that would be publicly available.
Yeah, Dave, that's your report. So do you have any response there?
Sorry, what is the question?
The most recent benchmark report.
Sure. Yeah. Right. But the most recent published one was in 2018. We have since done 2 iterations of that report. One was an internally used document, which was used last year. This year, which was used last year, and I think is the basis of numbers in this report. This year, we also have a benchmark report, which is scheduled to be published, but which is currently going through the review process. So we expect that out this fall.
Thanks. Other questions?
Go ahead.
Other questions on batteries or conventional?
Yes, there was one additional question on batteries that's probably we should get to now. Is there any plan to forecast battery storages above 4 hours in duration?
So right now, the battery technologies are based on lithium-ion costs, and we've broken them apart by energy and capacity components. So you can create batteries longer than that. It's unlikely, something longer than 10 hours with lithium-ion. There's probably competitors out there that would take advantage. So like that would be able to compete with that. So we currently use these costs to model durations up to 10 hours in our modeling work. So these can be used for any duration you want. At some point, they'll become cost prohibitive because the energy component will be too expensive at the really long durations.
Yeah, and in terms of some of those battery-specific questions, NREL does use other tools to look at some of the competition among different battery chemistries. So I think moving on, the next section is about the financial cases and methods. And so here, Dave, would you like to fill everyone in on your new report and how it's used in ATB?
Absolutely. Thanks, Laura, for the opportunity. So this year, with collaboration with DOE, we decided to spend more time and resources trying to do a better job of benchmarking the financing costs and future scenarios in the way that we do our other assumptions in the ATB. So we performed a data-driven exercise where we looked at the cost of financing for various technologies. These technologies in the ATB, because there is a wide variety of ways that renewable energy projects and conventional energy projects are owned and financed. We chose a specific but very widely used ownership and financing structure, which we felt would be better able to compare technologies and over time as things might change. So we looked at the ownership structure in which an independent power producer with a long-term PPA or power purchase agreement is financed. For renewable energy projects, the difference for natural gas projects is because of the data we collected, they're also owned by IPPs in these financial assumptions, but they sell their power through quasi-merchant contracts. So, and I should also say that natural gas is what we benchmarked all conventional electric technologies for financing goes, as far as those costs, because natural gas represents the vast majority of all conventional energy project finance in the future. The exception to everything being consistent is that coal, like in previous years, we added a 3% adder on the WACC, which is consistent with what EIA does. Anyway, so we collected all this data you can see in the bottom graphics, it represents various types of data that we collected. Far left is all-in term debt interest rates for loans initiated over time. The middle is the debt service coverage ratio and the different probability of exceedance levels by technology. And then the last is to the right is the after-tax levered cost of equity by technology. So really trying to use the data to inform our numbers, both for now and in the future. We built cash flow models and attempt to determine leverage. And we developed, similar to previous years, we developed 2 financial case scenarios, one an R&D case and one a market policies case. The R&D financial case assumes that there are no tax credits and no change in interest rate. The market and policies does. And I should also mention that we do sort of 2 different financing benchmarks. One is during the construction period, and the other is during the operating period to account for different levels of risk. So it's particularly meaningful for geothermal technologies. Not that it didn't impact all of them, but for geothermal, in previous years we had based off the data, numbers that were higher than what's seen in the marketplace for during operating period for financing costs, but didn't take into account all the costs during construction. And so this year, we're taking into more account the different levels of risk between construction period and the operating period, and we're able to be more consistent in that way. So, Laura, if you wouldn't mind going to the next slide. So these are our results. This is the debt fraction as far as the results for based off of the data. You can see the market and policies case, the debt level during the term debt level, I should say, in the operating period goes up over time for certain technologies. That is because those are the technologies with tax credits, and as tax credits slowly phase down, the capital that sort of was used, that was facilitated by the tax benefits, is now taken place by debt. So less tax equity, more debt. You can also see a slight decrease in debt fraction between 2025 and 2030, and that's because we assume that we're in an unnaturally, based off of, not just assume, but based off of data, we could say that we're in an unnaturally low level, or historically low level of interest rates, and so we show interest rates rising between 25 and 2030. In the R&D case, you can see that there are no changes because there's no change in interest rates and there's no changes in there's no tax credits. And then I think, is there a final one? There might be yeah. So this is sort of, you can see the WACC, right? So financing, you could is not necessarily an indicator of economic competitiveness. So as I mentioned before, the interest rates go up. The debt levels go up without the tax credits, but obviously tax credits are there for a reason. People like them, and so while the WACC is going down with the reduction of tax credits, that doesn't mean that the LCOE is necessarily going to go down. And as you can see, the WACC doesn't change for the R&D case. I guess, is there one more slide, or? Yeah, so you can see, right, as I was saying, the WACC, you can see the LCOE going down for some of these technologies, and then the LCOE goes up, and a part of that is due to the fact that while there is obviously the benefit of having a lower WACC, it's not necessarily made up for by having no tax credits. So all I have, unless there are any questions.
Yeah, the first question, what financing assumptions are used for storage?
That wasn't part of our analysis, so I'll let Wesley for this financing study.
Yeah. So our storage, we've just used default values for it, other than the lifetime is shorter than the other technologies. So you'll see that. So we incorporate a shorter lifetime, and then we have the maker's schedule specific to the storage. But otherwise, we're using default values for things. A lot of it is we're still learning a lot about solar financing costs. This is kind of the storage side is a work in progress on our end.
And one other question on the financing, would you expect or how would you expect the ownership structure of the project to affect the cost of equity and cost of debt?
Sure, yeah. Right, I guess it sort of depends who's owning it, right? For example, and this is discussed more in detail in the technical report that accompanies the ATB that is just released. It goes into this stuff more in detail. But there are we model also utility ownership in the paper, and in those sort of situations, it sort of depends on the technology. So in a lot of scenarios, there isn't a difference in the cost of capital, depending on what the project, the technology that's deployed, unless there's a regulatory reason for that. So you might see something that's cheaper for some technologies and more expensive for others. Also, typically, based off of, again, historical reportings, that the cost of the debt, or the amount of debt on a project at the utility level is corporate, not necessarily project-based, may have historically lower rate leverage levels than project finance. Happens for a lot of technologies without tax credits, but there's also the fact that there's complexities. Again, it depends if the technology uses tax credits or not, but for the ones that use tax credits, there are complexities in how utility, that a project that's owned by a utility sort of passes the benefits of that those tax credits onto, at the end of the day, the ratepayer. So that sort of gets a little bit complicated. And obviously, sort of besides the sort of utility ownership IPP model, there's other different within even within an IPP, there are different types of projects and different IPPs, and so that's going to that have different financial risks, and so that's going to impact the cost of financing as well.
Thanks. One more, if you could comment on why the weighted average cost of capital for PV decreased so much from ATB 2019 to 2020.
Sure. Last year we didn't. In previous years we didn't really benchmark financing costs in the same way. We relied primarily on EIA data, where we took sort of groupings of technologies by sort of the amount that they're deployed in the U.S. and sort of bucketed them, and sort of in that way tried to sort of approximate how financing might be different for different technologies. But there was the only data that was sort of we relied on was EIA stuff. This year, we went out and we talked to a lot of financiers and developers and lawyers and bankers and all sorts of folks, and and looked at projects, the data we collected for individual projects and groups of projects and all those sorts of things. So the reason that it's lower for PV this year is because that's what the data showed.
If we have time for one more, someone was wondering if the debt figures near 80% were borne out from evidence by actual developers.
So I'm trying to think if there was any 80%, but maybe go back, or if you wouldn't mind going back a few slides. But yeah, perfect. Right. So so the ones that are, so most of them are 75% or below. Some of them are a little bit higher. But those are scenarios that we haven't really seen yet in the US, because those are technologies that have tax credits. So I guess the question is, in these hypothetical situations, what would the debt be otherwise without tax credits for these technologies? And I guess so intrinsically you're not, or implicitly you're not going to have that, because that doesn't exist. But what we did do is we looked at other countries without tax credits, and it sort of finance in different ways. And what we saw was that our numbers without, when we calculated without tax credits, were fairly similar and actually lower than other markets. The amount of leverage in other markets that didn't have those tax credits. So I feel pretty comfortable with it. There are obviously other things that are going to impact leverage in other markets, such as like the rate of return. If you have a higher rate of return on a project, then it's easier to lever a project up, things like that. But yeah, I hope that helps.
So Dave, maybe just talk through, so the highest debt fraction that's shown here is in the R&D case, it looks like, for the commercial and residential PV technologies. So is that number coming from the data from your finance report, or is that number coming from somewhere else?
Right. So, sorry, Laura, I should have explained. So what we did was we did look at leverage and did look at data for leverage. But the leverage in this report is based off of modeling exercise based off of data about debt service coverage ratio, because those things don't exist, because these type of situations don't actually exist in the market. You can't actually have data about sort of what will PV look like without tax credits, because that's it doesn't exist. So we relied on debt service coverage ratio values, and based off of the debt service coverage values and all of the other assumptions in the ATB, like capex and capacity factor, and also are the numbers for the cost of equity and the cost of debt, we were able to calculate what those leverage levels would be based off of the various assumptions. And that's what we're looking at here. So the reason that, for example, commercial PV looks like, I think commercial PV is the highest, is because it has relatively low level interest rate. It has higher cost of equity than utility PV, which ends up producing a higher LCV, allowing for higher interest rates. And its debt service coverage ratio requirements are relatively low compared to other technologies, as shown by the data.
Okay, and that actual number is going to be something like 76%, so not quite the 80% that the question asked. And so if I could maybe try out paraphrasing, the direct answer to the question would be that that 76% line is not empirical data from commercial PV installations, but the debt service coverage ratio is consistent with what was seen in your empirical data. And the reason that it can't be empirical data is because we don't have the counterfactual case in existence where there's no tax credit, but you did compare your calculation from the model to places where there was no tax credit internationally.
You should have answered.
Did I get that?
That's a much better way of saying it. Thanks, Paul.
Well, I couldn't have answered it before I heard you. Okay, so that's kind of the summary. Brian, were there other questions from the audience?
Not at this time.
Okay. So I'll go ahead and wrap up, and then we'll take general questions about anything that's left. We're very excited to bring you the ATB product another year. And the vision for this product in the long term is that it does continue to be a flagship analytic product from NREL. We're very interested in facilitating access of all of you in the audience as well as anyone else. So, please let us know if there are things that are getting in the way of that. We value credible, consistent, transparent, timely, relevant, and public data. And we would love to hear if we need to take other data into account. So please let us know any suggestions. And our technological scope includes current and future energy technologies and systems. We do try to bring you a perspective from the National Laboratory and DOE systems, and we're trying to reach out across as broad of an audience as possible. So we really welcome any feedback that you would like to provide about the ATB and invite suggestions for improvement. So the references at the end of this presentation are those referenced in this slide deck. There is a much more extensive set of references for the ATB itself, and that can be found under the About ATB section. Similarly, these are just the acronyms for the presentation. A longer set of acronyms and definitions is available. And we will turn now to general questions and comments. Just before we do, please note that you can now sign up for updates to the ATB, and we would really welcome your sign up and your permission to contact you about other purposes. As we develop the ATB, we're interested in getting user feedback, and so we would love to have your email and your permission to contact you both with updates and for your suggestions about improving. So with that, Brian, are there other questions coming in? Should we go around the table technology by technology, or what's that question list looking like?
Yeah, there's definitely a few for each technology. I'll start with a general one, though. Are there projections on when this updated ATB will be incorporated into the NREL standard scenario projections?
Wesley, that's probably one for you.
Yeah, so every year we produce a standard scenario that comes out after the ATB. The ATB feeds into the standard scenarios, providing the cost and performance assumptions for the scenarios we run. So yes, the 2020 standard scenarios will be out sometime this fall once things are done there.
So thanks for that. Let's start with an onshore wind question. Given some markets are already suffering curtailment, and that you would expect the sites under development to be lower wind speeds, what accounts for the increasing, or the, sorry, I lost it. Here we are. What accounts for the capacity factor increasing over time?
Yeah.
So Tyler, would you like to fill that?
Yeah, can you hear me, Laura?
Yep.
Okay, good. Yeah, so the increase in capacity factor is a generalized assumption for these lower wind speed sites with integrated advanced controls and advanced wake steering techniques. So yeah, you do see our assumption of increased capacity factor for these types of sites. However, you do see an impact as well of CapEx increasing due to the additional, advanced control systems you're introducing into the system, in addition to more complex, perhaps, terrain and accessibility for the installation of the projects.
So I'm not quite sure that answered the question. I guess I heard it more to be about the overall system cost as there's more curtailment. And Wesley, maybe you would want to weigh in here as well.
Well, I think that,
Yeah.
I mean,
go ahead, Wesley.
Oh, go ahead, Tyler. I was just the ATB doesn't include curtailment in it. So if you want to include the effects of curtailment, that's where you have to go outside the ATB and start using other tools. So we do that at NREL by applying the READS tool, which captures curtailment and how it's going to impact the competitiveness of one technology versus another.
Yeah, I agree with that statement. ATB does not consider curtailment issues.
Thanks. Moving on to PV technologies. We didn't have a slide on residential and commercial PV, but someone was clearly looking at the website and was curious what causes the kink in residential and commercial CapEx in 2030? What assumptions are changing at that time?
Right. So I guess I didn't say this for all of them, but and I don't know, maybe this, Laura, you could mention this for others. I don't know if it's useful, but for the PV, for all of the PV scenarios, what we did was we built a 2030. We benchmark current costs and 2030 costs using techno-economic analysis. So that's how that was what informed 2030 numbers and 2018 and 2019 numbers. For everything in between, we did straight line difference reduction or whatever, increase, if that would be the case. Although I think it's just decrease. After that, since we thought it would be, who knows what's going to happen in 2050. As far as like specific technology improvements. Thought that was a little bit beyond the scope. What we did was we assumed that there are three cases. There's the conservative, moderate, and advanced case. Basically, for the conservative case, we assumed that by 2050 they would get to where the moderate case was in 2030. And for the moderate case, we assumed they'd get to where the advanced case was in 2030. We assumed that the moderate case in 2050 would get to where the advanced case would be in 2030. We actually also did a breakthrough case that we mentioned in the literature, but a specific case in the ATB of sort of what would the ATB look like in the advanced case look like in 2050. And so that's a straight line approach. So the difference is sort of the hop between those cases. And I'm not exactly sure. Go ahead, Laura. Yeah.
Sorry, Dave. I missed what's going on in 2030. Like how did you get those numbers?
Oh, sorry. The 2030 numbers are our techno-economic benchmarks. That's what all the improvements and changes that we described in the report are captured in our 2030 estimate. So that's how we did a modeling exercise for advancements, technology advancements. That's what's going on in 2030. That's the primary forward-looking view of how sort of what changes, and everything else is sort of based off of that. Does that answer the question, or did I miss?
I think so. That's great. Thank you.
Yes, thanks. Moving on to utility scale solar. There was a question asking for more detail on the transition from using watts DC to watts AC. And the person asking the question was surprised that the LCOE decreased even with that change. So can you comment on that?
So the LCOE should not be impacted by the units we use. Hopefully we did the numbers right, because the LCOE we assume, like with all technologies, that it's going to an AC grid, and so the units are in AC. So so there really is no change to the LCOE, and maybe that's, sorry, I wasn't clear in the slide that the blue line for LCOE is not in direct current. It's some other things. So really the reduction between 2019 2020 from an LCU perspective is these other things, the differences in capex costs between this year and last year, in which the differences in capacity factor, and then the differences in financing costs. And you can't exactly see the difference as far as capex go, because they are in different units, but suffice to say that at least for them, and this is the moderate case, in the moderate case, capex numbers are lower in the moderate case between this year and last year, and capacity factors are higher, and so all things being equal, it's a lower LCOE. Increase the denominator, reduce numerator.
Thanks. For the next question, are there future plans to model any hybrid systems, such as PV plus storage or hybrid wind solar storage, as compared to the separate technologies?
So I'll answer that. So there is a lot of work underway around hybrid systems and storage technologies at NREL, and essentially ATB will draw from that work for future updates. So we do hope to include additional data in that area for sure.
And just a quickly 5-second plug that our benchmark report will have a PV plus storage capex and LCOE estimate for current, not for future, but current costs.
There are two housekeeping questions that I think we might as well address at this time. First is, will the questions and comments be listed in the available docs after this presentation?
Jackie, do you want to say a word about what the outputs from the WebEx and in terms of the video and transcription will be?
Yeah, so we'll release a recording of the presentation, which includes the audio and the slides that were shown. We don't typically include the questions. Laura, I think that would be in your corner if you feel the need to put together some sort of document that lists some of these questions and answers, but typically we just release a recording of everything that was discussed within the presentation.
And that has the transcription as well, right?
Correct, yes.
Like captions to the recording, yeah.
Yes.
Okay, thank you. Brian, other questions?
Yeah, so then the other housekeeping question was if anyone in the audience has follow-up questions to the material presented today, what is the best way to ask those questions, both in technology specific or general questions?
Yeah, so the ATB website has a contact us area, and you can submit questions via the contact us. You can also register at that same part of the website. So hopefully I'm displaying that. And we field all of those contact us questions, and we do try to respond to everyone.
Thanks. So there was another question about details in getting the benchmark agreements for offshore wind costs. Could you provide more details about how we got that data?
Philip, do you want to?
Sure. Yeah. So thanks for that. I'd like to point you to a report that was published analyzing the power purchase agreement for Vineyard Wind, insights for estimating costs of U.S. offshore wind projects. There we've sort of documented the methodology to arrive at a metric that we think is comparable to levelized cost of energy by factoring in the PPA price schedule and a cash flow model, estimating sort of the revenue from capacity sales, the monetized value of the investment tax credit. So basically, by capturing all of those factors, we think we get a metric that's comparable to LCOE, and then that allows us to validate our bottom-up LCOE estimates and dissect them further. I can include the link to the report in the chat window.
Great, thanks. This question was specifically for solar, but I think it sort of applies to all of the technologies here. Are there existing and/or projected gaps between cost and price for any of these technologies, or where might an analyst find price data such that they could make assumptions about profit margins?
Dave, would you like to field that one?
Sorry, could you repeat? I didn't.
Just for
sure. So
how to get data on that?
On the finance report?
No, on the technologies. Any data to support assumptions about the difference between cost and price for the technologies, especially PV.
Oh, sorry. A good question. So I guess I would recommend reading the various reports on historical reports on our NREL's benchmark costs and how that, and we sort of have discussed like the difference between cost and price, and then also the various reports on reported pricing that LB&L puts out, and sort of how that might differ from benchmark costs. That's the best as far as sort of current benchmark costs. Unfortunately, our latest published report is from 2018, so we'll have to wait till the fall to see our new numbers. But similar for the I'm not sure what's going to happen with the reported pricing numbers. But yeah, it's also historical by nature.
Wesley, I wonder if you would want to comment on that, perhaps from a modeling perspective, how cost and price are considered in some of NREL's models.
I mean, the answer is largely in terms of what Cost and price mean a lot of different things to different people. So I mean, I think one of the things that could happen is that you have a cost of something, and then you have it costs this much to make it, and then this is how much the price is. Here's how much somebody's pay for it, and those could be different depending on your definitions. Typically, in the way we model things, the cost and the price are the same thing. So the price paid is the cost, and that cost includes the profits needed to make to be able to sell that technology and have it be sustainable. So in our modeling work, the cost and price are typically the same thing going into the model, and then being computed there for deployment based on the values they could provide and the services that are needed.
And as far as typical assumptions about profits needed, those are risk-based.
Well, the profits would be built in, so like you'd have a developer overhead, or like the engineering firm that's developing, like those would be a part of our overnight capital costs, would include the profits needed by the people who are making stuff to make money. So I mean, there's various pieces of the supply chain, different people are making profits at different parts of it. Those costs are rolled into that overnight capital cost number, and then they get fed into the model, and there could be additional profits that are made based on the values that the services provide and how much they get paid for those. But then now that's just that's a market question. So it gets really that's where this whole price cost thing gets really complicated really fast. So I don't know that there's a simple, easy answer that could answer this, other than it depends on the specific application where you're drawing your boundaries for prices and costs.
Okay. And Dave, does your new report provide some insight about the profits required along the way?
Sorry. Yeah, I think I misinterpreted the question, but Wesley did a much better job of answering. Yeah, so we build up the cost of the PV system, and so one of the costs to whoever's buying it is the profits margins built in. And we detail sort of what that profit is for each technology, and sort of how it fits into the total cost of a project, or the total price, depending on whether you're the buyer or the seller.
Okay, so maybe the concise answer to this question is, or the for more information answer is that this report, Feldman, Schwab, and Bollinger, just published, would provide some insight, as well as for PV specifically, the 2018 benchmark for PV, and then the forthcoming new benchmark for PV that we anticipate publishing this fall.
Yeah, only the Feldman, Schwab, Bollinger thing doesn't spend too much time on cost versus price. But if you have questions about financing, certainly there. But yeah.
But it has stuff about profit margin required.
Not well. I guess it depends. Right, it's a good point. I guess it depends if you're thinking about the cost of energy, or the cost, the upfront capital cost of the system. So certainly for the cost of energy, it would.
Okay. Other questions?
There was one housekeeping question, wondering whether the slides would be publicly available.
Yes, so this slide deck will be published as an NREL publication, and the website will link to it. So the NREL.gov, the general website for NREL, has a publications link. All NREL publications are searchable from that link. And then the ATB website will also link to this presentation once published. And it should be published within the next day or so.
Thanks. Another question came in about plans for future technologies. Any plan to include insights on wave energy in the future?
Tyler or Philip, would you have thoughts on that?
I don't have any direct thoughts. I don't know if there's been discussions within the wind and water program about including water in the ATB. That'd definitely be something to follow up with NREL management and the DOE team.
So Laura,
actually comment.
There's a number of questions in here about new technologies that we might add. One about biopower, one about nuclear small modular reactors, and I would say every year we evaluate new technologies that we could add. Part of it is there work out there that we could use to develop projections if that foundational work hasn't been done? It's a pretty big effort for us to add a new technology, because it would mean doing the work to understand the technology enough to be able to make projections for how it's going to happen. So the first piece is just, is there enough stuff out there already to be able to make that projection, and then what the appetite is across both analysts and the people who fund the work to get it included. So sorry, somebody else had a comment here. Let's go.
Yeah, my comment was just going to be that the latest version of the System Advisor Model tool does have a wave energy model. Now, obviously, the user is responsible for inputting all of the costs, but that is available at sam.nrel.gov.
Great, thank you. Any other questions?
I think that was all that I had prioritized. If anyone else saw something they wanted to elevate.
And if your question hasn't been answered, it may just be that it's more specific than we want to go at this time, but we will try to follow up with you offline. And if we don't get to you, you're welcome to use the contact us feature of the ATB website to get us that question. Okay, anything else? So I think hearing none, I will wrap up the session and wanted to thank all of our presenters and participants very, very much. Always great to launch the ATB, and we hope that it's very useful to everyone. So thank you very much, and take care. Goodbye.
Thanks, Laura.
Thanks, Laura.